So we have an example. The man is in a moving train, is at rest with respect to co-passengers, but he is in motion with respect to passenger outside the train. Okay, now we will see the different types of motion. So first we will see the motion of crawling ants. Crawling ants are what? They are moving in a line. Second, we will see the motion of cockroach. So cockroach is what? Cockroach moves on a surface. So its motion can be considered as two-dimensional on surface, and the ant can be considered as one-dimensional. So this is motion in a plane actually. So that is also two-dimensional motion. Third, we can see for any flying object, suppose we have bee. So honeybee motion is what? 3D motion, or it is motion in a space. So what are the different types of motion? The motion of ant is straight line motion, that is in one dimension. The motion of cockroach is two-dimensional motion, that is on a surface or in a plane. Third one is motion in 3D, that is for any flying object. So that is motion in space. So what we learn is, if some object is constrained to move along a straight line only, so that is one-dimensional motion. So example, if you say real life example, the ant, or if you see example of a mouse movement of a mouse inside its hole, so that is also one-dimensional motion. But movement of any animal or any object on Earth's surface, that can be considered as 2D motion, because that is motion in a plane. Okay. So that we have already discussed scalar quantities. What are the scalar quantities? What are vector quantities? So okay, what is path length and displacement? Path length or distance traveled, we say. So what is the these two things? The total distance traveled by an object from initial to final point, initial to final position, is called path length, and the shortest distance between initial and final position is called displacement. So for example, we can see if this person is going from home to college and then college to McDonald, then path length will be what? Home to college, the DHC, the H for home, C for college. So DHC, this one, and then DCM, the college to McD. So the path length will be how much? Home to college plus college to McD. But displacement, the displacement will be direct, directly from home to McD. Means it will be direct. It will not be including the path traveled. So displacement is independent of path traveled. So path length is displacement in some cases. So that is the we are going to see. If an object moves in a straight line and it does not return in its path, then path length becomes the displacement. You can see that person is going from here to here. So path length is HM, that home, H for home, M for MACD. So DHM, this distance is path length, and displacement is also DHM, because this person is not changing its direction, and it is the person is not returning on its path back. So these two are same in this case. Okay, another example we can see, the person is going to MACD, then returning back to home. So what is displacement? Displacement is 0, because initial and final positions are same, but path length is not 0, because he has gone to MACD and then returned. So path length will be more. Path length will be what? Summation of these two, means DHM, the home to MACD and MACD to home, but displacement will be 0. So what we can conclude is the magnitude of displacement may or may not be equal to path length traveled by an object. Magnitude of displacement is always less than the path traveled. Magnitude of displacement for a complete motion can be 0, but corresponding path length need not be 0. For example, suppose a car starts from this place and travels to whole city and comes back to your place again. Suppose a car starts from home, travels to whole city and comes back to same position. So what will be its displacement? 0, but the distance traveled will not be 0. Okay, now we will see what is uniform motion. So what is uniform motion? So uniform motion is if an object is moving along a straight line covers equal distance in equal interval of time, then we call uniform motion. In other words, we can say it is having constant velocity. So you can see example in 10 meter distance is covers in 1 second, next 10 meter covers in again 1 second, third one 10 meter again covers in 1 second. So what is speed? Now we define speed. The rate at which object covers distance is called speed. So it is scalar quantity that you are already knowing. It is scalar path length divided by time taken. Velocity is what? The rate at which object changes its position. That is called velocity. So position in a given direction. It means displacement. So displacement per unit time is defined as velocity.